Okay friends, so now we will look at some numericals from our solid state. Okay, and I'll cover all the aspects that I had mentioned about in the previous video about all the concepts. I'll cover all the concepts, most of the concepts over here, which are actually asked in exams. So let us look into the first question and let me take a good color. Okay, great. I hope it's not that dark, huh? So it says over here, the diffraction pattern of a cubic solid has an intense 110 Bragg reflection, but the 100 and 111 Bragg reflection are absent. The structure of the solid is. So what are these? These are the Miller indices, and I told you there are some rules to find out. Like as for SCC, all the HKL values are allowed. For BCC, only when H plus K plus L is even, then it is allowed if it's even. For FCC, HKL has to be all even or all odd. So what is over here? It says has an intense 110 Bragg reflection, but these two are absent, so all are not allowed. So it cannot be SCC. So is that SCC? Yes, primitive cell. I can cut this out. ECC is not actually that important. So it says 110, but not 100 and 111. So you can see like in 110 is allowed. It's not all odd or all even. So I can cut out FCC. So 1 plus 1 is 2. So like an even number which is allowed for BCC. So over here it's just 1 and over here adds up to 3. So which are odd, which are not allowed in BCC. And that is what is the case. So BCC is our answer, right? Let us go to the next question. It says a solid AB has NaCl structure. If radius of the cation is 120 picometers, the minimum value of radius of the anion B minus will be. So it says NaCl has, as we know, NaCl has FCC structure. The radius of cation is 120 picometers. The minimum value of the radius of the anion will be. And for FCC, you need to know that it has actually, if you remember, I told you FCC has a coordination number of 6. Therefore, your therefore, if you remember the chart that I showed you of the radius ratio chart, the RS plus R minus value for that is from 0.414 to 0.732, right? And it over here asks that for the minimum value. So what value should you take? So we know this radius, which is 120 picometers, R plus. We don't know R minus. It is equals to, so R minus is equals to, there has to be some X over here. So for a minimum value of R minus, X has to be very large. So we'll take X as 0.732. And that will give us our answer, as you can see from these steps. If the denominator is high, we get a low value, right? And the value that we get is like 120 by 0.732 in picometer. Okay, a crystal system, next question, atom A is at the corners of the unit cell, B is at the center. So A is at corners, B is at center of the cell, and the oxygen atoms are at the face centered position. What is the formula per unit cell? Okay, so it says that A is at the corners, B is at the center, oxygen atoms are at the face centered position. So as I said, the corners contribute 1 by 8, the center contributes 1, the face contributes half. Okay, so A is at the corners, B is at the center, and oxygen atoms at the face centered cubic. And yeah, so there are like 8 corners, so 1 into 8 into 8 is gives us 1. There is only one center, so 1 into 1 will give 1. There are like 6 faces, so half into 6 into will give you 3, right? So the value that we get from over here is AbO3, and this is our answer. Right, I was just checking it and we got the right value. Next question then. The value of B11 cubic resistor is 325.6 picometers. The value of D33 is. There's a trick for this. You see D11 and D33. Okay. Now we can also use Bragg's reflection, like Bragg's reflection law. How is that we can find out sine theta, and from sine theta value we can again put like d3, but we'll use that in a later question maybe. This formula 2d sine theta equals to n lambda. We have d value, we have lambda value. We can put n equal to 1, we can get the sine theta value, and then we have sine theta value and lambda value, and we can then find out the unknown d that they're asking. Sorry, once we get sine theta from our first value, we have the like sine theta value and the d value, and then we can find out the lambda value, the d3. But also another trick is that this over here, that dn, hn, and kn is equals to d111 by n. So this is actually equal to what was the d11 value, that is equals to your 325.6, and n is over here 3, so 325.6 by 3. Okay, even a mistake over here, this should be 3, and answer will be 108.5 picometers. That's the answer. Okay, let us see some more questions now. So those were from 2011. Now we'll see some questions of 2012. So first question is angle between two planes represented by Miller indices this and this in a simple cubic lattice is. So what are the angle between the two planes represented by Miller indices? Okay, let me just take my pen again. Okay, great. So I told you in the previous video there's a formula for calculating the angle between two planes. The formula is this. Okay. Okay, sorry for that. Let me try and erase this. Great. So the formula is this. Okay, and over here we already have our uh, HKL values, right? These are the Miller indices given. HK, this is, you can say H1, K1, L1. This is your H2, K2, L2. And cos theta is the angle between two planes. What is the question asking? The angle between the two planes. So cos theta angle between two planes is a formula. Just put the H1, H2, and K2, L1, L2 values in the formula, and we'll get an answer from this. So this is just mathematics. So I'm not going to details. If you want to know, you can watch my previous video. Metal crystallizes in FCC structure with unit cell side of 500 picometers. If the density of the crystal is this, the molar mass of the metal is close to. So as I already told you previous video, the density question is very famous. And what was the density formula? As I told you, Z into M by A cube into N, where Z is number of atoms, M is molar mass, A cube is volume, and N is Avogadro number, right? So what it says in FCC structure. So what do we know in FCC structure? Okay, in FCC, how many like atoms are there? So FCC, there is one atom via the corners. How is one atom? Like 1 by 8 in the 8 corners, so it will give you 1. And there are 6 atoms in the faces, but they have like half contribution, so it's half into 6. So this will give you 1, this will give you 3, total is 4. The details of this are given in the previous video. Okay, so this actually is Z. Okay, this should be Z. FCC is equals to 4, right? So what is given? Its FCC structure is given. It's given unit cell size is 500 picometers. Picometers is what? It's 10 to the power minus 12 meters, right? And density of the crystal is given. So D is given, right? You have to find out M. So we know Z, we know D, N is Avogadro number, and we know our unit cell. So A cube, as I said, A cube like 500 to the power minus 12, a whole cube, because A cube is the formula for any cube, right? So we know all our variables. So we need to just make M the subject and put all the values. Just be careful of all the units that are here. This is gram per cc. Okay, so you need to, is gram per centimeter cube. See, over here the density is given in gram per centimeter cube. This is in picometer. You have to convert picometer not to meter but in centimeter. So this is 10 to the power minus 12 meter, and it is 10 to the power minus 10 centimeter, right? And they did exactly that, 10 to the power minus 10 centimeter. whole cube, which is 10 to the power minus 30. And they got the final value, which is again mathematics, so I won't go into it. Okay, now packing fraction, which is again an important question. Packing fraction of simple cubic lattice is close to. I did the whole derivation in the last video, and the answer was 52% or 0.52. Right? How it's done? You see the whole. What is packing fraction? Packing fraction is the amount which is packed by the spheres or the atoms in the lattice. So the whole lattice volume is a cube, and the volume of the spheres is 4 by 3 pi r cube. You need to express A in terms of R, and for SCC A is equals to 2R. So this will be 2R whole cube, and if you do all the things, R cube will cancel and you get 0.5 as the answer. Okay, next question. A crystal P, okay, I think this will diffracts from 111 and 200 planes, and but not from 110 plane. Okay, that was one part of the question. The question is very big, so let us break the question into different parts. So it diffracts from these two planes but not this plane. While the crystal Q diffracts from this and this planes but not from 111 plane. From the above, we may conclude that. What we may conclude from the above is that, okay, that they're telling us to find the kind of crystal that it is, right? So as I already just showed in the previous video, it's 111 and 200 and 110. So you get to see a pattern like this is all odd, this is all even, this is odd and even. Okay, okay, while the crystal Q, uh, okay, it says but not from 100 plane. Okay, okay, then it's fine, right? So this is all odd, this is all even, so it's not from 10 plane. So this is what? So this is odd and even mixed. So we have an all odd and an all even combination. So it cries out for FCC. The next part we have, while the crystal cube diffracts from 110 and 200. So addition of this is 1 plus 1 2, this is 2. So but not from 111. This is addition of this is 3. So this has to be BCC. So I am saying that this uh, P will be FCC, BCC will be Q. So my answer is A. Is this the correct answer? Yes, it's given A as the correct answer, right? So one last type of question that I wanted to show you is over here. A metal crystallizes with cubic close packed. Okay, let me again get my pen. With a close packed structure, the sine square theta values of the Bragg reflections of the Miller planes are given. That is HKL values are 0.8, 0.14. The sine square theta values are given for this and this plane respectively. Unit cell length is. So let me just write down the formula for Bragg equation, which is nothing but 2d sine theta equals to n lambda. Now they're giving us sine square theta values. So if I just square this whole thing, 4d square is equal to n squared lambda square. So n we take as 1, so I can just like 1 square is 1, so I'm just removing this, right? It says cubic closed packed structure. The sine square theta values of Bragg reflection Miller planes are given as 200 and 111. And the sine square theta values are given. The unit cell length, that is telling us to find unit cell length. So we have to actually go into the depths of it. And so over here, what we can see is the lambda values will be same, right? So what we can do is exactly as I'm written over here, like nd. So this is n lambda actually. N lambda equals 2d sine theta, n square lambda square 4 d square sine square theta. And for 200 we have sine square theta value as 0.18. For 111 we have sine square theta value as 0.14. So when we put this whole like n square lambda square in this whole Bragg equation, and we put the HKL value. What is the HKL values? 200. So it will be 2 square plus 0 square plus 0 square, which will give you 4 over here. And 4 and 4 gets cut, and you will get your lambda squared by 0.18 equals to a square, and you get the a value. So actually, we did not have to actually use both the cases. We just used one of the cases, like see, because we have the sine square theta value, we have the d value, right? sorry, we don't have the d value, but we have the lambda value. And but actually we don't need to find the lambda value. That was the trick, that the lambda value was given in the variable itself. So even if we don't have the lambda value, it's fine. So we just need one set of values only to get the answer. Okay guys, so this was just the main idea of questioning or solid state, and we just applied most of the concepts we learned, and I hope you learned something. So have a great day ahead and enjoy.